Hello, and welcome to Module 5. In this module, you'll be introduced to GIS, which stands for Geographic Information Systems. This will transform not only how you think about creating site context for your projects, but also how you understand the way cities store and organize geographic information, such as what you're looking at here. So I'm going to continue with a presentation with that I not only explain what GIS is, but also this idea of spatial thinking. So this is a report from the National Research Council called Learning to Think Spatially. And this report opens with this famous painting called The Geographer by Johannes Vermeer from 1669. And this is really critical because even centuries ago, measuring and interpreting space was considered one of the most important intellectual pursuits. So the core argument is that spatial thinking is a fundamental skill. It's a foundational skill that is not just about maps, but it's about understanding relationships between locations, patterns, and distances. And I think your education as an architect really prepares you for this pursuit. So today we interact with spatial data constantly. Every time you search for a location or get directions on your phone, you're using a geographic information system. And in this case, we're using GPS for that. And these systems go beyond navigation. They combine your location with weather, traffic, nearby points of interest, and other data layers. And all of this information is spatial and is being collected by a series of sensors or series of efforts done by cities or individual citizens. So we're living in an era of massive data production. So this is cover of Economist from early 2000s with this title Data Deluge. And this was the first time where the idea of a large amount of data that we're pursuing was foregrounded in culture with conversations around big data surfacing. And big data refers to large amount of data that is not really suitable for our standard tools of information processing that everyday people use, such as Excel. And therefore, introduction of machine learning and other statistical models allow us to work with large amounts of data better. But nevertheless, I want you to understand that the contemporary world, it is it allows us the capacity to not only produce large amount of data, but also synthesize large amount of data that we can hopefully use in better building our environment. So at the basic level, data is a mark or a trace that represents a portion of the real world. So one piece of data on its own is not very useful, but once you have two or more, you're starting to see comparisons. Then patterns and then meanings are starting to emerge. So here's an example of raw spatial data. Each row is an earthquake event with coordinates including magnitude and region. So on its own, it's just a spreadsheet, but as soon as you map it, you start to see patterns. This is one of the most famous examples of data visualization in historic context that's often referred to as the first time when we were able to layer geographic information systems and with the use of visualization begin to create synthesis and change policy. So in 1854, John Snow mapped cholera deaths in London and discovers that they clustered around water pumps around in popular parts of the city. So of course, this was not computer generated, but he utilized existing maps and then began to using dots and X's map either location of pumps and or deaths from cholera. And he started to then synthesize and draw conclusions that this was due to water pollution. Another example is this map by Fathom, and Fathom is led by Ben Fry, who was seminal in creating some of the early accessible data visualization tools, including processing. So this is a street map of the entire United States by Fathom, and every line is a road. no labels, no colors, and yet you can immediately read the density of cities, the grid of the Midwest, the emptiness of the West. The data itself becomes the visualization. So when you zoom in, you start to see the difference between planned grids and organic road networks and the way topography shapes circulation. All of this is information stored in GIS data that they were able to visualize using this tool called processing. So spatial analysis is the set of information techniques for studying entities using their geographic properties. So in design, it is most commonly applied as the human scale through analysis of geographic data. So then what is GIS? So GIS is in geographic information system and is any system that integrates, stores, edits, analyzes, and displays geographic information. It utilizes location as the key index variable, and everything is tied to coordinates. So in this case, longitude, latitude, and altitude in order to map physical places on Earth. So here's an example created by Sensible City Lab that are based at MIT Media Lab. And this is depicting taxi trips in New York City. On the left, you're looking at the raw data lines that are black and white. And perhaps if you're just looking at that, you might think that thicker line means more importance. But as soon as we're starting to look at color coding, we can start to understand that actually red might have more significance. Here we're actually looking at density of travel. And although there's more cars traveling along the edges of the city, these are the highways that go along the city, but actually they're traveling faster. So therefore it's using this green color. So there's many different ways that not only we can visualize, but we can embed information such as color to represent information. So there are many tools for working with GIS data. So for instance, ArcGIS by Esri is the industry standard and has been for over 40 years. In the past decade, tools such as QGIS have surfaced that allow you to work with more free and open source alternatives. And then there's Grasshopper, and with that, with the series of plugins that Grasshopper offers, we can actually start to create a really rich ecosystem for integrating GIS in architectural practice. And that's really exciting. So these are several Grasshopper plugins that connect to GIS data. So on top, you'll see the standard softwares that I mentioned. And then on the bottom, these are some of the most popular plugins. They're working with different types of GIS data. You might have different types of GIS data. Today, we're only going to be using with one type called OpenStreetMap. And if you go to Food for Rhino and search for GIS, you will certainly find many more of these, but these are some of the popular ones. Now, in order for us to understand how Geographic Information System or GIS is stored, let's think about them in the way that information is structured. So there are two main types. One is a vector data structure, and the second one is a raster data structure. So the first structure, which is vector data, so here, for instance, let's think of an area that is made of lines. So this could be maybe lines that construct a boundary of a building, boundary of maybe a lake. And these lines are made of points, and then points are stored as coordinates pairs. Each point, line, or polygon is called a feature, and each feature has attributes associated with it, like a name or a type or a height, any information you might need. Then the second structure is the raster data, and think of it like a grid of pixels, and each cell is assisted with a series of values that are embedded in there, and these values are assigned. So higher resolution means smaller cells and more accuracy, but also larger files. We will mostly be working with vector data in Rhino for GIS. However, there's some plugins such as Elk or such as Gizmo that they have capability to work with satellite imagery. But Rhino mainly works with vector-based, boundary-based, in this case, points, lines, and polygon-based GIS information. So here's an example of a vector-based GIS data. Here we're looking at part of Manhattan in New York City. And because it's vector-based, you can zoom in and out without losing your resolution. And here we're looking at only blocks. And there's the key part, which is if you click on any building or anything that is represented here, and this could be maybe a boundary of a park, a block, or in this case, specifically building, it has GIS data embedded in there. So this data could be the year that a building, for instance, was constructed, it was renovated, the zoning information, height, name, address, you name it. And all of that information, like a folder, is stored. But if you look at the root, it's ultimately a spreadsheet of information that is tied to geometry that we can then track and utilize. And that allows us to then continue building on this knowledge. As you can imagine, it takes a while to construct this information, embed this information, but once that is constructed, then you can just keep making this even richer. So I just want to summarize here that skilled spatial thinkers, in this case specifically GIS, would allow you to extract information meaningfully from error-laden data sets. It will allow you to synthesize different types of data. You can begin to work with large amounts of spatial information. You can use different visualization modes. You can detect hidden spatial patterns and regulations, and you can infer spatial patterns and relationships. And all of that will further enrich how you're working with your design, and it will change the way that perhaps going forward you might want to create your site information. Okay, so let's go back to our Rhino Grasshopper environment, and we're going to be working together to construct a similar definition together. So here we're looking at part of city of Tempe. This is Arizona State University. This is Tempe Town Lake. And we're going to look at how to crop this information and then embed them into using a plugin called Caribou, and then extract certain information that we're going to be looking at. So before we look at Grasshopper, we need to go to a website for extracting our GIS information. So let's visit openstreetmap.org in your browser. And if you just type openstreetmap.org, it will take you, in this case, to Portland. That's kind of the default of the setting. So that's where the initial developers are set up. Over here, you could go ahead and type anywhere you would like to go. I suggest we all work in City of Tempe. We're familiar with the context. And I recommend submitting City of Tempe as your final assignment. And then here we are. Let's go ahead and zoom in. And I'm going to here zoom in an area. Let's say here's the main campus of Arizona State University. Here's the lake. Here's a road with a bridge. And you could begin to zoom in out, but every information that we're seeing here is encoded using GIS and is extractable. Let's take a look at this page a little bit further. So it has the option for us to log in, but it's not necessary for us to do that. So you can just work with it without logging in. It has information for us to show your location, understand layering. So let's click on that. So if you click on that, you'll see that there's basically different types of information that's layered in OpenStreetMap. And OpenStreetMap, you can think about it as Wikipedia, but for mapping. So it was constructed or it was initiated in 2006 as an open source approach to mapping. So collecting map information, generating maps, and it has a very active community surrounding it, which allows people to contribute to this. So you can think about this as a map system that's always changing. So if you're looking at an area that maybe currently might be maybe not as high resolution. We'll see that today, for instance, not every buildings have, let's say, height associated with them. But maybe you will go back to the same region in a year and it will have more resolution. Now, larger cities such as New York City, Los Angeles, London, Paris, they have more GIS data because you have more people that have been using them, and more data you produce, more people will start to use that, right? So there's kind of that aggregation that happens by default. But I would say Phoenix has a decent amount of information. It's certainly enough for you to start your project. And then if you need further information, there's other tools that you could use. And I would link to a presentation where it will introduce you to other types of add-ons that you can use for GIS. That's not part of this tutorial, but if you like to go further, then you can definitely go further with that. But for now, let's select an area that we like. And at any point, when you want to export your data, here we can go to the Export tab here, click on Export, and you will see the latitude and longitude of the area that we're looking at. So this is our latitude, so we're in the northern hemisphere. And then this is our longitude, right? So we're west. So if this number was negative, we would be in south, southern hemisphere. If this was positive, we would be in east. And of course, these are agreements that are global agreements about longitude and latitude. There's also altitude, but altitude is not represented in OpenStreetMap by default, but this data could be projected on topography surface. It's not possible to do that with the plugin we'll be using, but there's other options that I'll be mentioning as we go further in the tutorial. So for now, I want you to just understand that as you start to move your browser, then this latitude and longitude boundary changes. Let's say generally take an area like this. And then we can also click on this option here called manually select a different area. And that gives you a rectangle which you'll be able to crop your region a little bit further. So I'm just gonna go a little bit kind of below the campus site. You can certainly change this and see how much you can import. It's not a perfect region that we're looking for because else you'll be able to replace this. And one thing that you'll notice is that over time, as you are maybe checking different regions, if you click on export, which we'll do next, you might get an error that you are trying to export too much information. So that is an API error. In that case, you want to just select a smaller area. But if you don't get any error, so I'm going to click on export. Let's see if we get an error. Yes, so it says you requested too many nodes. Limit is 50,000. So if you get this error, that just tells me that this area is too large. So then let's go ahead and select a smaller area. But let's say what happens if you do want a smaller, like a larger area. In that case, you can just crop two different files and then import them side by side, right? You just want to make sure that you have a little bit of an overlap so then you'll be able to get the regions that you want. So let me try a slightly smaller area and let's see if we're able to export this time. And there it is. So you're going to then be exporting a file type called map.osm. So the reason that I have this 3 index here is because I already have 3 different, I've tried to download it 2 more times. So, and every file that you download from this website is going to be called map.osm, which is fine if you leave it as is, but I recommend renaming. So I'm going to go ahead and grab this file and I'm going to just move it to my desktop. And I'm going to rename this as tutorial 5.1. And I'm going to call this Tempe. Great. So you can certainly call this whatever you like, as long as you're able to keep track of your information, then that would be great. All right, so since we have our file already, the next step for us will be installing our plugin. So for a moment, I'm going to take you to Food for Rhino. And the specific plugin that we're going to be using is called Caribou. So just go to Food for Rhino. You are not going to be actually downloading and installing from here. I just want you to be familiar with where you'll find more information about the plugins. So Food for Rhino website, you'll be able to log in, or you can just browse. If I were to just type GIS, you'll see that there's quite a lot of different add-ons set up for GIS. We can sort them based on type, based on popularity, when they were last updated. Now, depending on the type of different GIS data that's available. So today we're only working with OpenStreetMap. There's also shape files, and shape files are basically standalone files. You wouldn't be downloading them from a website. You will be, for instance, extracting them from maybe a city website or every library. So for instance, ASU library has a shapefile. So shapefile is the name of a specific type of GIS file. So again, depending on the type, you might want to use different add-on. And in the PowerPoint presentation that I'll be giving you, it explains what different types are. Now, today, the reason that we are going to be working with Caribou is due to the fact that it's the only plugin that works in both Windows and Mac. And this is important for our course because you have some of your colleagues that are using Mac. And I think this is a really good also plugin in terms of the type of information that you can sort and download. And it also has this great tutorials that you can reference. It has example files. So I think it's the best option for our course because you might be using Windows or Mac, right? So just keep this in mind that this is a really great option, but it might have some limitations as you advance more in GIS. Okay, to install Caribou, the best option would be for us to go to Rhino. And before I do that, I'm actually going to go ahead and close this example, and we're going to open Rhino and Grasshopper together. And you're going to open your Rhino file. And this time we're going to be working with large objects because we're working in urban scale. We don't need to work with small objects. We're going to be working with large objects, meters. So we're working in meters because OpenStreetMap embeds information in meters, and that would allow us to then verify information. And if you're ever not sure, one website that's really great is Google Earth. And with Google Earth, they have this measurement tool. So for instance, here I'm looking at Tempe Town Lake, and this edge of the bridge is a really great way for me to verify information. And you can use your ruler here to verify things, right? But you're working in meters, you should be certainly fine. So in our command line, and whether you have Grasshopper already open or not, it is not critical. We can go ahead and you just type manager, and you'll see that there's different types of manager, and the one that we want to work with is called package manager. And if you ever see an error pulling up your package manager, you might want to check your updates. There's a few other things. If you come across any issues opening your package manager, send me an email. But for most of you, this should open, and it allows you to access all the possible add-ons you can access. So if you're using Rhino 6 or older, then you do want to follow installation from here. And as you see here, it also has an installation file. It would be similar to what we also discussed in module 3. But for most of you, this should be fine. And again, if you have any issues, email me. So let's go ahead and look for Caribou. And it tells me what the the latest version is and information about the website. So this is the developer information. I think it's really well documented. Now, I do already have it installed, but I'm going to go ahead and click on it regardless. So go ahead and install, and once it's completed, it's going to tell you that you just need to restart. So let's go ahead and do that. So close your Rhino and open it again, and make sure that you're opening in large objects meters. And now next time we call Grasshopper, by either calling it from the command line or from my icon here, then we should be good to go. And you should see this add-on called Caribou. And if you open that up, you'll see that you have 3 different subtabs. And the main ones that we're going to be working with is these 2 tabs. This one is just about the software. There's nothing here you'll get that's different than what you already saw in the pop-up window when we were installing this. So it's a pretty lean add-on, and I think it's a really good option for what we need to do today. Okay, fantastic. In parallel, and you don't need to do this, but I want to explain this, I want to also introduce you to what a GIS add-on might look like in a more robust sense. So in this case, we have Urbano, which is another add-on, and you'll see that in this case, Urbano has way more components. And in this case, of course, you will be able to do many more things, but I don't think this is suitable as an first introduction to GIS. This works with multiple different types of GIS files. So you can see that OSM or OpenStreetMap is one of the types, but it also allows you to work with shapefiles. So shapefiles, as I mentioned, is a specific type of encoded GIS, as well as just GeoJSON. So this is a raw form of geographic information. So just know that GIS might come in multiple different types. And then there might be features about topography and other things, which is capable of being kind of introduced in Rhino. It just requires more kind of understanding of the platform, which I encourage you to delve in after this. But for now, we're going to proceed with Caribou because it will give you a really strong foundation for understanding what is possible. Okay, fantastic. So now that we're working, I'm going to just go to my perspective view, and we're going to go to our first tab in Caribou called Parse. And Parse has 3 different types of information we can parse. It has extract buildings, it has extract nodes, and it has extract ways. So if I go back to the presentation we were looking at earlier, I'm going to go back to the page where we're looking at here. So points is clear. So that one gives us information for geometry that is utilizing points. So these could be points that are allowing us to construct lines or polylines, or these could be standalone objects such as, let's say, a location of a tree or a specific point of interest that's represented as point. And then ways, these are kind of, let's say, a term for polygons. And this is one of the things that you need to get used to, which is depending on the add-on, they might be using a specific lingo. So if you hover over it, just make sure you read. It says load and parse way. It says, or known as polyline, data from an OSM file based on its metadata. Now, in some add-ons, ways might be introduced as roads. Roads might be introduced as highways. So I'll talk about those, and just know that these are some of the language that we're kind of borrowing from spatial sciences, which is the science of using GIS and remote sensing in order to basically reconstruct the world. So don't worry and get overwhelmed by any of this. Just all you want to do is to just read the documentation or just hover over the component and it'll give you information. So let's go ahead and bring each of these down. So let's grab an extract building component, and you'll see that it's orange. So orange means it's still missing information. Let's grab extract nodes. and let's grab extract ways. So let's see what they have in common, what the differences are, and just organize them a little bit. So all of them are looking for OSM file path. If you hover it over it, it says the path to XML file downloaded from OpenStreetMap. So all of them are looking for that. And then they're looking for this thing called OSM features. It says a list of features or sub-features to extract from OSM. It looks like they all have in common. The only thing extra that this one has is whether we want to extrude or make our buildings 3D or 2D. So it looks like that's something that has in common, and then all of them need the same two inputs. So let's then go to our select tab here. There's two options here only. One is filter tags. The other one is specify features. Let's go ahead and grab the specify feature component here. And you'll see that it is actually not taking input. So when the edge is cut off, it means that it is just providing output. And it says specify feature, it says no feature selected. So this doesn't look like maybe anything we've seen so far, but you always want to just hover over, and especially when you see components that have a little bit of thickness like this, or they have tabs, you want to just make sure that you're exploring what it is asking you to do. So sometimes you might want to right click or you want to double click. And in this case, when we double click, we'll see that it gives us this window where it tells me every single thing that's possible for me to extract. So just look at all of these capabilities, right? There's so many things we can extract. So from aerial way to buildings. If you open buildings, you'll see that there's different types of buildings we can extract. If you close this, let's go all the way down here, waterway, railway, highway, you name it, right? So it's really powerful. So what we're going to do throughout this tutorial, we're going to select certain types that we import. But first thing I want to show you is just what is in all of this. So you can either do individual selection, or here I can tell it to select all. Sometimes if you're not sure what's available, you can just try select all. So go ahead and do select all. Then we're going to tell it to update selection. So then if you hover over it, it tells you everything that is able to select. Okay, that's first step. Let's go ahead and connect our OSM features to OSM features. All right, so then it is also asking for, I'm going to organize this a little bit. It's also asking for OSM file path, right? So what is this and how might I receive this? It says the file path to XML file downloaded from OpenStreetMap. So that's exactly what we downloaded earlier, and I need to reference that. So how do I do that? If I go to my parameters under primitive, there's a component called file path. Or if you double click on canvas and type file, you'll see that it actually has a couple of different options for reading file. Now, depending on which add-ons or plugins you're using, these options might be different. Don't get overwhelmed. Just make sure that you're using this one called file path. And it should look like this. So it is still orange. It means it's missing information. And it is just requesting information. So if you recall earlier when we referenced, for instance, points or curves or anything from Rhino or anything that's outside of Grasshopper, we could use these containers. So whether it's a geometry we're referencing, or in this case, file path we're referencing, the logic will be the same, meaning we would right click right in the middle. We can do select one or select multiple. In this case, for file, we only have the option to do select one. But if this was, let's say, geometry or anything else, it will be select multiple. So for file, there's only one option. Click on select one existing file. And let's go ahead and select that OSM file. And don't worry about the naming. You can name it whatever you like. And then go ahead and open. Okay, so I hope you were able to open the file. You didn't get any errors. And now let's go ahead and connect this component to our OSM file path, then to the second one, and to the third one. And maybe you already noticed that your apologies, your preview changed in Rhino Grasshopper. Now I'm going to go to the top view. And you'll see that this is really exciting. I am starting to see and recognize the map that we cropped earlier, right? So if I go here, this is the river, this is the road, this is the boundary, and this is a lot of information that we were able to crop. You can start to make up some of the facilities, some of the buildings, and even, let me go to perspective view, you'll see that some of the buildings are in 3D. So just by referencing a file, we were able to actually construct a site. I think that's really exciting because any project you have from this point on, the first thing you want to do is you want to basically crop and just see what is available, right? So of course, this is exciting, but our work is first to see what's available and then start to clean up and see how much of this information we actually need. So first thing is first, let's go ahead and group this basically container. And I'm going to right click and say, this is my referenced OSM file. So then this way you know that you're going to be referencing this from outside. And we're going to then make sure that you see the same preview. So just know that under display, these are the ways that you can manipulate your icons. We've talked about this before. So I personally like to do draw icons and draw full names. So this way you're able to actually explicitly see and read things. Okay, so if you're able to see everything, we're going to one by one start to manipulate things and better understand what is actually happening inside this. Because if you recall, now that I double click, here I have everything on, which is exciting. I can certainly start to maybe just export this as is, but what are all of these points, right? So these are my points. So are these trees? Are these, let's say, signages? Like what am I really looking at? The next step for us is to use the same components, but better understand what exactly we're looking at. So then when you're developing your sitemap, you can easily extract information. Now, this information, such as what we're looking at, from any of these outputs, if I grab a panel, I can actually start to understand. So the first output for all of them, and I'm going to grab a node, a panel to see, the first output is always geometry. You can also do your quotation mark to extract this, right? So it's a BREP, so boundary representation or a polysurface. But then as I scroll down, you'll see that, yep, all of them are BREP. These are all the points, so they have coordinates. And then these are all the polyline curves, but then some of them are line-like curves. So they're lines. So if they're maybe a segment, right? So they don't have the entire thing, so they would be line-like curves. So one other thing I want you to start to look at here, and we've already started to talk about data trees, we're starting to see how we go from a single line, because it's a single file, to multiple line, because we're trying to ask for multiple features, to a dash line, because here we need to split information into different parts. Why do I need to split information? Because per each branch, if you recall here parameters under utilities, here I can grab a param viewer. Per each branch, so in this case, if we think about each building as a branch, so every single building is a branch, but it looks like some of them have multiple. So depending on how the data is structured, let's say per branch, there's many different information that I might have. So for instance, So I want you to not get overwhelmed here. Just take a look at my screen, and I'm trying to explain the data structure. So per building, and your information is going to be different because you maybe slightly cropped a different area. Just understand that per building, whatever that building is, there might be different information stored as part of their GIS. So per building, that building with that path, there's information such as location, the house number, the address, number of levels, and even, number of operations, right? So if it's a public place. But then as you start to scroll down, you'll see that some buildings, maybe there's less information, such as in this case, not number of levels so much, but the height, or just whether it's a building, what type it is. And even as we go further down, some of them have less information. So that's kind of the exciting but also frustrating part about GIS, that yes, there's data, but not all the buildings have the same information, right? So some buildings are 2D, some are 3D because maybe we don't have the level or the height information. Same thing with nodes. So I'm going to grab another panel here. And if I look at the output here, some nodes, so for instance, it tells me the address, and some it just tells me what it is, or like kind of minimal information, right? Same thing with let's say waves. These are the polylines. It tells me that, so for instance, this is a boundary of a parking, but some it gives me way more information, right? So even the type of surface, the electricity information and all other things. So therefore, depending on the area that you crop, depending on your project, you might have, let's say, more or less information per site that you're looking at, right? So I want you to keep this in mind as you're cropping your region. So if your output doesn't look exactly like mine, that's completely okay. I'm going to upload the exact same OSM file as part of the assignment. So if you want to just visit Canvas and download my specific OSM file, so you can certainly do that. You can do that by going to Canvas, and under files, you'll find the specific OSM file. But if you want to crop your own, that's absolutely fine, right? So actually, that's great practice for you to do that. Just keep this in mind so it doesn't get frustrating. All right, so now that I have all of those things, I'm actually going to select and delete these because they take up a lot of space. And along with that, we're going to look at actually manipulating some of the layers one by one. So for instance, if I'm looking at this region, one of the things that's very, very prominent is this Tempe Town Lake, right? Which is really critical. And let's say if you're drawing a site plan, you definitely want to visualize this. So let's see if we can isolate this. Now, the Tempe Town Lake boundary, which is here, it certainly is not a building, but it is kind of visualized as a boundary, right? So I can kind of start to see this, and it's definitely not a point, but it could be made out of points. So I'm through that process of elimination, I'm going to conclude that I can use my extract ways to extract just Tempe Town Lake. So I'm going to select the buildings and the points, and I'm going to turn off the preview. I'm going to use my middle mouse button to turn off the preview, or you can select and you right click, go preview off, or do Control Q, whatever you choose. Right now, I'm just going to continue with my ways. And let's proceed. So I'm going to double click on my specify features. And instead of having everything checked, let's go ahead and do select none. And if you scroll all the way down here, you'll see that there's actually two types of information that could help us. One is water, the other one called waterway. Now, of course, in an ideal world, maybe it would be something called a lake. But maybe in this case, I'm interested in water in general, and I want to see what is available. Because, for instance, in this case, we know that it's a man-made lake, but then there's other water bodies that are contributed to it. So let's say as our first test, let's go ahead and click on water and waterway. So I'm only going to select that, and then let's go ahead and do update selection, and then there it is. So it's giving me now the boundary of the lake, and then it's giving me this other waterways as well. Let's try to see if I can make sense of what the tags are telling me. So always use a panel, and you can see that, okay, it seems like the first one is the Tempe Town Lake. But then it's giving me also natural river. It's giving me different canals. So there it is. So I can either go back and through process of elimination, I'm going to go back here and say, well, what if I turn off waterway and just take a look at that? So it looks like that's a little bit closer to just having Tempe Town Lake. And it looks like, yeah, that is also another waterway. And as you can imagine, I can go back even further, and I'm going to open this and say, well, what if I don't want a wastewater? What if I don't want, let's say, a moat, right? So we can just have lake. But I think for the sake of this tutorial, I would just say, let's check anything that's water, and then go ahead and do update selection. And then we have these three branches, right? So it is extracting, think about this as three folders, right? And basically each of them then have one branch, and that's one branch is what we're looking at here. So I think that's a great start. And here we have these, and I can go ahead and even make a surface out of this. So let's go ahead and go to our surface tab. Under freeform, let's grab a boundary surface. And I'm going to connect the output of ways because this is basically my polyline. And go ahead and connect that. And there it is. So this is our lake. Now, if I also, let's say if I change my mind and if I go back and say, well, is there anything else I can maybe visualize as water here? Just click on this and tell it to update selection. So there's some bodies here, and you can see that, but these are actually mainly lines. So although there's some information there, there is something here, but it looks like it's basically mainly the three that I had. But hey, there's more water here. Maybe I can visualize and maybe other things here. So I want to show you in the next step one way where you could say that, well, if it is a closed polygon, then draw for me, because this is doing the drawing process. But if I look at the output, whatever is not able to draw, because let's say these are lines, it is actually giving me an empty branch, which is okay if you just want to visualize it. But what we could do is we can actually check whether a polygon is a close or not. And with that, I want to introduce you to a very useful tool. So basically, the output of ways is a polyline curve, right? And in order to set this up a little bit better, I'm actually going to go to parameters, geometry, and I'm going to grab a curve container. And the reason why we're doing this is because over time, you hopefully are going to reuse this definition over and over again, and setting this up in a way that you could easily understand what you're looking at. Because ways, let's be honest, it doesn't tell you immediately that these are curves, right? But there it is. If I look at the output, it's the same thing. And in this case, if I look at the output here, so some of these are polylines, actually, and some of these are lines. And even with the polylines, I don't know which one is open and which one is closed. So under our curve, under analysis, there's an option here where we can check whether something is open or closed. So let's go ahead and click on this. And it's basically a question. So it's going through each of them and it's asking, are you a closed curve? And I'm going to just use this panel over and over again. And the answer is true. Yes or no, right? And once we know this, we can then easily sort our information based on that. So for that, we're going to go to our Maths tab. under domain, we're going to look for a component, under sets, under list, we're going to look for a component called dispatch. And dispatch allows us to separate. And you use dispatch over and over again in past module, but here we're using it to separate whether geometry is open and closed. And I am teaching you this as a reference in order for you to basically utilize this over and over again based on different geometry that you might be importing. Okay, so what I want to check is whether these curves are open or closed. So I'm going to feed that as the list. So in this case, list of our curves. And then I'm going to provide whether it's true or false. And all the trues will come out of here. So these would be all closed curves, and these would be all open curves. So if I look at that, so these would be polylines that are open, or they're lines. And then instead of basically directly doing the surface here, I will just move it here, and I apologize for wires getting messy again. So I'm just going to replace the true output, right, to the edge input. Now, this is now just surfacing everything that is closed, but the color is still orange. The reason is that if you recall from earlier, and if I look at the output, we're still inheriting the basically the data tree structure. So in previous tutorials, we looked at this idea of flattening, which is getting rid of your data structure, right? So we're going to be able to then flatten our data, either right from here or right from here. Either one will be okay because I can either separate it and then simplify it, or I can simplify it and then separate it. So I'm actually going to do it from here. I'm going to right click and tell it to flatten. And along with that, I basically got rid of the data tree structure. Now this is a clean geometry, and it only basically surfaces what is closed. And this could be a very useful feature that we can later on use to surface our closed boundary for buildings, or let's say building blocks, or anything else that we have, right? So this is now ready for us to apply color to. So let's grab our custom preview under display, preview, custom preview. And let's make it blue-ish. So let's go to our parameters under input and grab a color swatch and go ahead and connect to the material and just select a blue color that you kind of like, that let's say in your map represents water. And then in order to make the preview a little bit more, let's say, friendly, I'm going to turn off my surface preview, select and preview off. But then you'll see that there's also these lines that we want to visualize, right? So the lines are also necessary because in this case, it shows maybe any other type of stream that maybe there is no boundary yet. So that is something we could visualize coming out of the basically the false. So this is checking whether it's open or closed. And I can still connect this as well to this, or I can provide a separate color. Actually, I'm going to delete this. And the output of list B as well, I'm going to connect it to my geometry input. So hold your, hover over this, and then make sure that you're holding shift so you can connect two wires to the same input, right? I'm just going to show you, if I don't hold shift, it's just always going to replace it with whatever is the latest. But if you hold shift, you'll get this plus sign, and then you can connect more than one. Great. So that's a really good way for you to visualize this. And at this point, I can also delete this just to make this more compressed. And I'm going to also delete this. And I'm going to actually group this with the rest of this. And I'm going to select all of this together, and I'm going to do Control G. And I'm going to right click and just name this that these are my waters. So basically, we want to start to separate this further. So then this way, let's say if you want to bake this, if you right click and bake this, then it will be easier for you to know what layer is what, or you can even just take a screen capture from your Rhino preview, and then you can use it as part of your sitemap. Okay, so next thing we're going to do is we're going to import some other features such as our buildings. And in order for me to have more control over color and how I proceed with this, I'm going to actually create a slightly different specify features for each of these. So although my buildings, extract buildings is connected to the specify features, I'm going to go back to Caribou again and grab another specify features. And that will give me a little bit more control over how we're extracting things. Also, you can easily use this in a modular way for your future definitions. So first thing is I'm going to connect this new specify features to OSM feature. And right now, because this one doesn't have any information, it is still basically orange. Then to make the wires kind of less confusing, I'm also going to disconnect this specify feature from the point one. So you can either right click and go to disconnect and disconnect it from here, or you can hold control and then just disconnect the wire, right? All right. So now we're going to just focus on buildings. We can double click on specify features, and here nothing is selected. So let's go ahead and just mark buildings. And if you open buildings, you'll see that, of course, with buildings, there's many different types of buildings. And this is then something you can explore further. If you're doing any site plan, you could isolate, let's say, the industrial from, let's say, more cultural and other ones, retail, you name it. So this becomes a great way for you to separate features. So for now, I'm just going to check buildings, go ahead and do update selections. And then now, earlier I turned off the preview. So if you turn the preview on again, you'll see that now these are my buildings. And you'll see that in this case, I have all the 3D buildings. In this case, all the 3D buildings are already extruded. And this is a default setting of our output heights. And if you hover over it, it says if true, only output buildings with height will be generated. And if it is false, only output buildings without height will be generated, right? So you do want to keep this to true, but let's try to see what happens if I turn this to false. So let's go to our parameters under input, grab a Boolean toggle. And if I turn this to false, you'll see that the buildings are there, right? But they only, I'm going to go to top view. It basically visualizes everything that doesn't have height. And then if it's true, it only visualizes things that do have height, right? So it's a little bit tricky because how do you kind of consolidate that? Well, we can just have two options. And let's say maybe if you're doing a 2D, certainly you want to be able to show all buildings. Now, let's see what happens maybe instead of a true or false. Let me disconnect this. I'm going to use a slider instead, double click, and let's select a number. I'm going to just select a random number like 75 and connect it to height. You'll see that when you are, instead of a toggle, also using a number, it is basically because it's a positive number, it is treating it as it would be true. So I just want to show you this because sometimes instead of a toggle, you might see a number connected. And if the number is positive, that is kind of signaling true. If the number is negative, it is signaling false. But that number doesn't mean that actually my building is being extruded by 75, right? It is still giving me the same height. So the height is extracted from the file, and it has nothing to do with what number I'm connecting here. So I'm going to go ahead and delete this. But what I can do for visualization, I can double this effort, right? So I can have one that's true. And in this case, we're going to group these two together. Control G. And I'm going to go ahead and change this color a little bit because now we're something like that. And in this case, I'm going to say these are my 3D buildings. And then I'm going to make another copy of this. Control C, Control V. And then I'm going to make this to be false, right? So then now this is everything else. And I'm going to call these my 2D buildings. So, of course, right now there's an overlap, but I think this is a pretty great way for you to start to basically create a site that could be quite rich. Because for most of the, let's say, especially drawing based, when you want to show a larger site, a two-dimensional would definitely be sufficient. So in this case, if we look at, for instance, the output of your building, it is telling us that these are trimmed surfaces, right? So it is outputting surface. If I scroll down, these are trimmed surfaces. So this would be kind of similar to the way that we use these boundary surface in order to create these boundaries, right? Now, if you do want to extract the edges, in this case, you can go to surface analysis and, for instance, extract the edges, right, or the wireframe. So let me try that. So I can provide the buildings as BREPs. I'm going to turn this off. And here, these are the 2D ones. So if I'm looking at it here, so this is a little bit easier to see what has basically height and what doesn't. And depending on then basically because this is a Boolean, right? So it either is or isn't. Because this already is separating you based on what has height and what doesn't, you can also start to maybe if you want this for visualization, you can even extrude this if you like, right? So we can give it a try. We can either extrude the surface or we can extrude the wireframe. So this might get a little bit heavy. Let's give it a try. And we're gonna, if you see that this is heavy for your computer, you can turn it off. And this is quite standard practice in a lot of GIS tools. If it recognizes that building height is not there, it's going to just assign a value. And in this case, it could be a standard value. It's going to assume, well, a typical building, let's say in Tempe is 2 stories, right? Or 2 levels. And then based on that, we can assume where, well, every level maybe is between 12 to 15 feet. And then you can multiply that and you can have basically a generic site. Now, of course, some of these also, if we were to go through the tags, some of them will tell you that they have a level, but they don't have height. So with a little bit more advanced data mapping, you can extract the levels and then you can match to the height. We're not going to do that for this assignment, but just understand that it is very much dependent on the site. Now, if we were to just crop a city like New York City, you'll see that almost every building is extruded, right? So if you have a site for your studio, just try to crop and then see what's available. But if you want to just create a generic density, so let's go to our surface under freeform, we're going to look for extrude. And in this case, I can either extrude the surfaces or extrude the wireframes. The nice thing about extruding surfaces will be that, we would be just, it would already be capped, right? Versus this way, it would basically, we still need to cap it. But I'm doing this because I'm going to show you something else in a bit. So because I know this is going to be a heavy operation, there's quite a lot of things to extrude. First, I'm going to assign the height. So let's give it a unit z vector. Under vector subtab, grab a unit z. So I'm not connecting the buildings yet. I'm giving in the height. So then I'll avoid grasshopper crashing. And I'm going to give it a generic height. So in this case, we're going to, because we're working in meters, let's make a slider that starts from, let's say, 3 less than 12. So 3 meters in this case for a level. It's pretty much a little bit more, but let's just go with 3 meters for now. And I'm going to give it 1 point decimal. And let's connect 3 as the z value. Now, if you start to feel that your computer might lag, and this is something I'm telling you before, maybe it's a good caution. Instead of shaded preview, we can go to wireframe. And this would definitely make our operation a little bit managed better. So I'm setting it up. And then all we have to do is to just connect the building's output to the base. You want to give it a few seconds to operate, and then once it's good, we can just take a look at it. So now you could see that it's starting to look like a site. So basically we have buildings that are 3D already here, and then buildings that are 2D, but then I'm extruding it. This is basically 3 meters. And if you are, of course, depending on the city, if you feel like, well, a generic height is X and Y and Z. So I'm actually going to change this to 7 meters as a generic height, so like 2-story. So I think that's pretty good. And then there's always going to be exceptions, so surfaces that are not extruded properly. So this is one of those cases that we'll see that, well, is it better for us to, extrude the wireframe versus extrude the surfaces? I can also give it a try. Basically, the outcome would be similar. The only difference would be the capping, right? So actually, it looks like that one is an issue here, so it has nothing to do with this. Nonetheless, basically, you can either extrude the wireframe or you can extrude the building. I'm going to keep it as is, and I'm going to then group these together. And here we're going to just say, actually, I'm going to sample this color, make as default, Control G, and then here we're going to say extruding to the building boundaries. And then we can create a color swatch that then we can, in this case, merge all buildings, whether it's 2D or 3D, or you can keep the color separate. So it all depends on basically how you want to create your site plan, right? So let's go ahead and I can just copy this custom preview and color swatch, or you can create a new one. So custom preview and a color swatch. So in this case, I want to connect all the 3D buildings. So it already colors it that way. And I'm going to assign a color to it. So grab a color swatch. And let's say I'm going to make my buildings. Let's just pick a color. I'm going to do maybe grayish color. Actually, it's Arizona. Let's do brownish color. That color. And those are the 3D buildings. And then I want the 2D ones maybe slightly different or the same, again, up to you. But I could make a copy of this and then connect these as well. And there it is. You have basically your buildings, right? And this is certainly good enough for you to start to contextualize these, right? All right. So we have everything here. So this one, I'm just going to group it to itself and then say this is our extract to the building boundaries. And I'm actually going to turn it off because we don't necessarily need it, but I think it's good for you to have this. And I'm going to keep this here in case you need to visualize the content, but I'm going to connect it to tags. So then later on, when you come back to this, you can use this. Okay, so last thing, I'm going to just combine these a little bit better. Add to group. In with this. Add to group. And then I'm going to group all of this together, which is going to be all of my buildings. So I'm going to extend this so you could see it a little bit better. And I'm going to group this together, Control G, and these are going to be my buildings. Okay, so we have our water, we have our buildings. And next thing we're going to look at is extracting our roads or anything else we like. So at this point, let's go ahead and save our file. So we're using the same naming convention that we've done before. So I'm going to save my document and I'm going to save it as your first name, last name tutorial, make this 5.1. Save this on my desktop. And we'll use the same convention also for the Rhino file. Let's continue. So as you know, at this point, this is a very powerful thing that we can keep extracting. We can visualize things. And there's a lot that, we can do with this. But of course, with the roads, you're starting to understand interconnectivity and everything comes down to this file. So if I change my mind, if I slightly crop a different area, different city, everything is there. So it's very powerful. Okay, so let's continue with our roads, and we're going to proceed by going to our Caribou, and under select, we're going to grab another specify features, and we're going to connect it to our OSM features, and then let's double click on it. Oh, sorry, we're right now working with nodes. And we'll do the nodes first, and then we'll go back to creating the streets. So this street creation logic will be quite similar to what we did earlier with our lake. We just need to extract different types because basically streets and lake boundaries are the same. So with our point, with our extract point feature or extract node feature, we want to look at different types of GIS data that might be node-based. So for instance, one of the critical things that you will be thinking about is maybe any vegetation that might be around your site, right? So for instance, trees. Trees are really critical features in Arizona urban planning or any site. And it would be quite valuable for us to see that information exists, or maybe traffic lights or anything else. So let's go ahead and click on specify features. And I'm going to first go down here and we're going to look for nature or natural. And I'm going to open this and I want to specifically understand whether we have tree information, and you see that, yes, it's definitely there. I'm going to click on tree and tree row. And, I think that's a good starting point. Let's see if we find anything, because that could definitely tell you a lot about certain decisions you can make. So let's just click on these. So under natural, I'm looking at tree and tree row, and then go ahead and update. And just make sure that your preview is on, and you'll see that, sure enough, that's quite a lot of great information. So imagine every single point is a tree or a tree row. That is very rich, because that immediately changes maybe the type of analysis that you could do from a city, right? Or hopefully you understand that at this point, if you have, let's say, a project site, you can easily also add this information. So you can create your own list of points that then you can feed, etc. And let's just see what type of data is coming out of this. So here it's giving me nodes. So this is the city coordinates, but also it's giving me tag information. So for instance, is this a tree? Yes, yes, yes. Let's see if it gives me anything about, so for instance, for certain ones, it has the height, it has maybe the type of canopy and everything else. So as you can imagine, hopefully over time, we'll have information about every single tree, every single feature. So I think this is exciting. So let's try to visualize this. And usually with trees, this is a node, we can visualize this as a circle, right? So imagine you're making your site plan and you want to visualize trees. So these are nodes. We're going to draw a circle around them. So let's go to our curve tab. And let's go to our primitive, and let's look for a circle component. And all you need to do is to provide the nodes. But similar to what we did here, I actually want to go ahead and have a point component part of this. So go to parameters, geometry, grab a point container. And that's just for me to show you that, yes, nodes are points and they become the plane. So if you recall from tutorial 2, when we were looking at how points can be basically base of the frames or planes. So these terms are interchangeable. So these have now these radius. I'm going to delete this so we can see this better. So then we can increase this. So by default, that value is 1. Let's make a slider that goes from 1 less than, let's say 3 less than 10. Then give it 1 point decimal. So 1 in this case is 1 feet. So this would be a tree with 2 feet canopy. So that's quite small. So depending on type of tree, you might want to create this. So of course, sometimes this could mean maybe a cactus tree, right? So maybe it's difficult to visualize this, but I think for now we just want to understand these are green, points of interest that we can then visualize. So let's just say I'm going to keep this maybe around 2.5. And then let's go ahead and visualize this by creating a custom preview and creating a color gradient for that. So under parameters, under input, grab a color swatch, and I'm going to make that a green color. So anything, any color that you like. So now if we turn off the points, and in this case also this component, you'll see that now very easily you're able to see that, yep, there's these kind of boundaries of vegetation that we're looking at, right? I think it's quite nice to have that. Now, if we were to maybe visualize this a little bit more, we could surface this. So we could use, again, our boundary surface, under surface, freeform boundary surface. And basically you take the surface, you make it into a sorry, you take the circle, you make it into a surface, and then that's what you're visualizing here. And then we just turn off the preview for these. So there it is. So it's a little bit easier to see. So it kind of depends on the effect that you're looking for, but I think it's nice to have that. So there's that. Now let's see if there's anything else that we can visualize that's part of vegetation. So we'll do this kind of segment all the vegetation stuff. So I'm gonna open the specify features again. And it might just be that it might require points or even lines. So let's see. So there's rock, beach, cape, cave, right? So there's coastline. Of course, not all of these apply, but let's say grassland. Click on that. Let's see if we have maybe, let's say, stones, shrubs, and you can just try and see what you like. So it's doesn't need to be, you can look at this as an exploratory thing. And then let's go ahead and update and see what else is possible. So let's see, if I were to turn this on, you'll see that, in addition to these, they are maybe, let's see how much more. Yeah, it looks like it's actually not that many. So it looks like we got basically a lot of these things already covered. So yeah, there might be exceptions here. So the other thing is we can go ahead and just click on anything with natural, right? So it checks everything and just see what's possible. So this is where we could see maybe some other features emerging. And then this is also where maybe we could introduce to say, well, is there any natural boundary that maybe is going to require me to use a polyline? So this is where you can bring back some of the other ones. So under caribou, under parse, bring the ways and see if there's any, sorry, I just need to connect the OSM here. And then let's see if there's anything that we can extract. And you can see that, yes, certainly they are natural features, right, that are not node-based, because this one only it gives me the nodes, which I think that's pretty good, all the node-based things. But also these allow me to maybe understand other things like, grasslands or other type of green vegetation, right? So in this case, that is possible to track. So we can see here. Now, some of these are maybe, open, and some of these are closed. And it's certainly, if I go through, and this is what I want you to pay attention. So even under natural, there's this thing called water, right? So although we have water separately here, so this is where you kind of want to just spend some time seeing what's there. It might also be that under geological, we might find something. So I'm going to check that as well. So let's go ahead and update, and you can certainly see that, yes, it's changing. Now, I don't exactly know what each of these mean, and at some point, you don't want to add everything, especially if they're not maybe closed boundaries. But this is where we could recycle one of the features that we developed here, which is if you are a closed polyline, I'm going to go ahead and visualize you. So I can actually just reuse this part. And since I already have this here, so I can just go ahead and copy everything from this point on. This is one of the best ways that you could, just reuse a feature over and over again, because this has nothing to do with water. This is just any closed polyline that you're selecting. So go ahead and do select this, everything after this, Control C, Control V, and then just bring it down here. And then all I need to do is to just connect the Waze input to the curve, and there you go. You have your other features, and in this case, I'm going to just change the color. And in this case, maybe I'll go, a slightly different green. And this is where, the fun begins, right? So the problem is that right now, I'm going to change this a little bit. So right now it looks like when I'm changing color, the color of the water is changing, although I'm visualizing the water here. So what that tells me is that, just like I mentioned earlier, there's things here that maybe there's duplicates. It might just be that under natural, this water is actually referring back to the lake. So what if I turn that off? And you'll see that sure enough, now it deselected that, right? So just keep that in mind that some features, they might be, part of multiple categories, because you can just turn on natural and that gives you everything. Or if you just want to look at water, you could separate that, right? So I hope that's clear. And that's a very simple way for me to kind of isolate. And now we have water, we have trees, we have like some generic vegetation. And I'm going to just spend a couple of minutes cleaning this up for you. So let's go ahead and say the nodes are basically, these are my trees. I'm going to just group them together, Control G. And I'm actually going to change the color. And this is just best practice. So when I'm looking at this, I understand that's one thing, that's one thing, that's something else. Or maybe we do want it to be green. Since, we're working with vegetation, I'm going to do it like light green. Yeah. And then I'm going to sample this as the default. And then these are going to be my trees. And then these are going to be I'm just going to call it natural boundaries, because I think we're not going to go through and sort them. So let's imagine like these are our natural boundaries. Okay. Then we're going to group all of this together. And we're just going to call this vegetation or natural boundaries. So as you see fit, right? You can sort these, organize these. Okay. So I have these, actually, let me just desaturate this a little bit so you can see these a little bit better. And then this one, I think it's okay, just slightly desaturated. Okay, perfect. So we have everything here. Just make sure that you're periodically saving this. And last thing is that let's go ahead and introduce the roads. But before that, I want to clean it up a little bit, and I'm just going to turn off these points. So you can just select pretty much everything before this custom preview, and then your middle mouse button and turn it off, and there you go. It's beautiful, right? You can easily see your site plan, and all you have to do is to just bake them or take a preview, and you have your site map. So next time you have a studio assignment, you can just replace this and spend a little bit of time fine-tuning this, and there's your site plan. Okay, so let's proceed with our roads, and roads are basically more of this. So I can just copy this entire thing, but I need to be aware that this one is checking whether things are open or closed. But for roads, I actually don't want them to be a closed polyline. Roads are lines, right, that you just stop wherever the boundary is. So I can just go down here and continue building. And we're going to go back to Caribou again, use extract ways. Then we're connecting our OSM file to OSM file path. You've done this already. Then I need to use specify features and use specify features and connect this to our OSM feature. And let's go ahead and open this up. And we're going to go ahead and click on this option called highway. And then click on update selected, and there it is. And just see, like very quickly, you have a full site plan. So now this is every road that's there, right? So it gives you every single road that's possible. So it could be pedestrian, it could be for cycling, primary, secondary, bridge. But nonetheless, it's a really nice way to complete your map. And of course, we're going to go ahead and do further isolation. But before that, I want you to go ahead and install an add-on that we're going to be needing in order for us to better represent roads, because right now all the roads have the same value, the same thickness, but we can actually visualize them with slightly different thickness in Grasshopper as well. So please go ahead and make sure you're saving your Rhino in Grasshopper, and go ahead and go to your command line and look for a package manager, and open the package manager and look for a plugin called a human. And yeah, there you go. Human. Yeah, human. I guess for some reason it doesn't come up when I'm giving it a full name, but HUMAN, human. And human is a really great visualization add-on that you could use for a different thing. So select human and then go ahead and install. And once you're done with installation, you do need to restart. So close your Rhino, close your Grasshopper, and then go ahead and open it again. This time you're opening your Rhino file first. And again, verify that it's the correct file. We're in meters, and then go ahead and call your Grasshopper. And then open your latest file. And you should see the plugin added here called Human. And this is a really great plugin that it would allow you to display your Grasshopper preview with different line thickness and some other data visualization tools. And I think it's a fantastic plugin. So we're going to come back to this, but for now, we're going to continue first extracting what we want to look at. So in every city, when roads are constructed, there's a hierarchy of primary, secondary, tertiary, residential, pedestrian, cycling, and of course some have multiple names. So it could be a primary road that you allow cycling, you could be a tertiary road that you could be also residential. So it becomes basically a way for you to isolate information, but then you can use that information to, for instance, look at noise levels, right, or pollution levels, or anything else you want to analyze. So let's go ahead and spend some time understanding how the roads are constructed. So under highway, so depending on the data source, so for instance, if we're looking at shapefile, which is another GIS file, the roads are not going to be called highway, but in OpenStreetMap, they are called highways. And if you open this, you'll see that these are different types from, let's say, road center line. So to, some of them are maybe very specific, but motorways for sure, minor roads, paths, etc. So my recommendation is for now, just for us to understand, to have a little bit more control over this, my recommendation is that we uncheck everything. So basically select none. And then under highway, let's scroll down and only select a couple of things, which is primary. And go ahead and click on primary link as well. Then look for secondary. Actually, let's just go with the primary one, and then let's see if we have just primary. So just primary and primary link. And you'll see that, yes, indeed, this is a primary road, right? Rural and all this ones. So this is a great way for you to start to introduce hierarchy. And ultimately, it is giving me, in this case, a polyline, right? So what you could do is using the human plugin, you can start to introduce different colors and different thicknesses to lines. So let's go to our human plugin, and under display, we're going to look for a component called custom preview line weights. And you'll see that this is exactly like our custom preview. It just works with line thickness. So the geometry that I want to preview is the ways. And it by default has this shader, and it has a thickness. And then whether we want this to be absolute or not, basically, when I'm zooming in and out, if I want it to be updated. So first thing, let's change the shader. So this could be pretty much a color swatch that we've used before. So because this is a primary road, and I know there's a lot of traffic there, I'm actually going to use gray tone for roads. I'm going to make this 0, 0, 0. So make it a black color here. And in this case, okay, I have my primary road black, and this becomes a way for you to, let's say, maybe show impact, but you can feel free to change this color to anything you like. I would just like to see a gradient here, meaning you're changing the color tones as they change. Then for thickness, let's make a slider that goes from 0 less than to less than 10. Let's give it 1 point decimal and connect it to thickness. And you'll see that, yes, you're able to actually change the thickness in screen. And that becomes a great way. I'm a big fan of screen captures for you to just make a map and maybe do a screen capture here. And then the absolute, let's grab a toggle under parameters input Boolean toggle. And if I do basically absolute, it actually is changing the thickness, whether I'm zooming in and out, versus if I don't, then, it kind of keeps the same. So I'm actually going to just go with the default setting, which is false. I think that's okay. So actually for this tutorial, I'm going to go to true, and then you could see what looks good depending on your zooming factor, right? Okay, so these are my primary roads, but because I want to repeat this a couple of more times, I'm going to just adjust this similar to what we did. I'm going to grab a curve container, and I'm going to connect the ways, and then I'm going to connect the geometry, right? And I'm going to just group this together and Control G, and I'm going to change the color to maybe more of a grayish color. And I'm going to say these are my roads. In this case, these are my primary roads. All right, so as you can imagine, all we have to do is to just modify this. And sorry, I need to add this to this as well. So these are my primary roads. I'm going to Control C, Control V. And all we have to do, and maybe I can actually, yeah, maybe I can start from number 8 here. So this is primary, and then for secondary, we could go 6, etc. Before anything else, I'm going to say this is going to be my secondary road. And I'm going to change that value to 6. That's 8, that's 6. And then I need to remember that I need to uncheck primary and then check secondary. So secondary roads and secondary links and see what's available. So these are my secondary ones. And if you like, you can also change the color, so I can make it a little bit lighter, right? So you can see primary, secondary. I will then go to tertiary. We'll see Control V, but you get the idea, right? So depending on your site, you could keep all of them the same or change them. So here I'm going to go to tertiary, and some areas they don't actually have tertiary. Tertiary, and I'm going to change that value to 4. And then maybe I'll go lighter here. So if they don't have anything, we'll change this to residential or something else. But then we go here and then go to highway again, uncheck secondary, and then go to tertiary, which I need to also change the spelling. There it is. So these are the tertiaries. So there it is. So if I start to turn these off, and even these, you'll see the roads. So these are the tertiaries. And let me just quickly see what happens if I turn this to false. I don't know if it's quickly going to be easier to see. Yeah, that's a little bit overwhelming, but yeah, I think let's keep them true. We would just play with this. Maybe this needs to be a little bit thicker or a little bit more, something like that. And then you get the idea, right? So we'll try another one. Usually you want to look for the residential ones because there's a lot of residential. I can just go here and look for residential, or if you're looking for anything else, Sherry residential. And you can select some of these together, like it could be unclassified, so that might be another one. Let's see, let's just say, or Living Street. I'm gonna check that. Yeah, we're just gonna do Living Street and residential. Kind of means the same thing. These are the residential ones. And I can change the colors to something else. So I can go like darker, but then, thinner, but you get that, right? So let's just see what is the type that maybe will give me more of the types here. I'm gonna do Control C, Control V. Let me see. And then we can always have a category, which is like everything else. So highway untagged. Let me just quickly check a couple things. That's not much. And that's why it kind of requires you to, let's see, is there a lot of, there's not that much. I'm gonna actually make the color in a way that it stands out. I'm gonna, and depending on the area, right, these things are gonna be different. So I'm gonna uncheck that. Let's see if there's any cycleways. Let's see if there's any um, um just the general motorway. Yeah, let's try to see all the motorways. And then some footways, right? There you go. So that kind of covers a lot of them. I think what I would change is I would separate the footway from motorway, because that you'll see that there's, those are the main freeways and other things. So I would, maybe it's okay to keep them red, or I'll keep them like kind of red black. Um, let's say if you're making a pollution map, then I would make them thicker. So those are motorways. And let's say these are motorways. All right, and then let's just do one last one, which is footway or walking, right? And we go here, and that's quite important when you're designing. Where are the, where can people actually walk? And here, like you can then, also look at cycleway, maybe footway and cycleway. There it is, right? So that's a lot of what we're looking at, and maybe we go a little bit lighter. We go a little bit thinner, but hopefully you get the idea. All right, so as you could see, it's a very powerful way for you to just start from any side and in, very short time. And so these are kind of the overlap where you have it. You can start to basically construct these really like kind of good starting point, right? So of course, after this, you can go back and model, you can do other things. So I'm going to stop the tutorial here. I'm going to just group these types. So I want you to make sure that you have primary, secondary, tertiary, residential, motorway, and footways. I want you to group this together, and we're actually going to make this color kind of light color here. So you can certainly just crop any side and utilize this. So I'm going to just quickly overview what we did. So with the Caribou plugin, we started from one site that we cropped from OpenStreetMap. I'm going to upload this specific OSM file so you can reference if you want to see exactly the same thing. We extracted the waterway, and we wrote a little condition here, which we're checking whether a polyline is open or closed. And if it's closed, then we're giving it a surface. If not, we're creating a line. This is one of those cases that we can also introduce the human preview option here if we want to visualize water a little bit thicker. It's not necessary. Then we proceeded with extracting our buildings, both 2D and 3D. To turn off the preview wherever it's not necessary. So you basically, the main preview you could just keep on is the custom preview. So we have the 2D and 3D, and this is using our extract building component. We use extract node to extract our tree location, and these are now visualized using these circles. And then we also utilize our extract ways, or the polyline extraction, to extract these generic vegetation. And then lastly, we extract basically roads by going through our highway, which is the generic category, and then selecting different types. I want you to certainly stick to this types: primary, secondary, tertiary, residential, motorway, and footway. However, I want you to also extract two different types of information, whether this is two different types of roads. Maybe try to extract the cycleway as well as maybe the rocks, or try to extract two different types of roads. So in addition to what I'm showing here, please go ahead and extract two different types of information. and just add it down here and as another addition. So using the same OSM, go back to Caribou and create your own extract nodes or extract ways. We've already done the buildings. You can just copy this twice and then extract different types of roads or extract nodes and then see anything else you can find. So I want you to just think about what else might excite you. And I am going to look forward to seeing that. So thank you so much for following this tutorial. I hope this gets you excited about GIS and the potential of using data to visualize any site. Thank you.